Now, before we go into the anti-logarithm of numbers, let's deal very quickly with the logarithm of negative powers, that is of decimals, of pure decimals like this. When you have 0.3231, 0.000954, 0.00006038, how do we find the logarithm of these values? Now take note. What's the power of 10 here? Obviously, the power of 10 is what? Times 10 raised to power minus 2, right? So how do we write it now? We write 2. This is signifying minus 2 now. Minus 2 plus our normal value we get. Minus 1 plus the normal value we get, which is what now? 32 under 3 with a difference of 1. Now check for 32 here. 32 under 3, 1, 2, 3, will give us 0.5092 with a difference of what? Of 1. 32 under 3 with a difference of 1. Now with a difference of 1, we have what? 1 actually. So plus 1 will give us 0.5093. 0.5093. So plus 0.5093 gives us what? 1.5093, but it has this sign on it. When you see a sign on this, when you have in the logarithm part of a particular number, they give you the logarithm of a number, and you are seeing this, it shows that that value or that logarithm is actually the logarithm of a decimal number, Okay, looking at the second one, obviously we can see that what? The power of 10 here is what? Minus 4. So what do we write? Are you following now? We have 954. That's 95 under 4 with a difference of what? 0. The 0 here now. If there's no value located here, we put invisible 0 there. So with a difference of what? 0. So 95 under 4 with a difference of 0. Now look at 95 here. Under 4. This is under 0. Under 1, 2, 3, 4. To give us what? 0.95 under 0, 0.9795. Now with a difference of 0, it means there's no difference, right? Good. So this is our answer here, 0.9795, which will give us minus 4.9795. Moving quickly to this one, we also have what? Our what now? Our power of 10 to be what? Minus 5, raised to power minus 5. So we write it like this. Take note, the integer part is the power of 10, whether for negative logarithms, which is actually what? The logarithm of decimals, numbers less than 1. If you are being taught in your classes, it might be taught under the subtopic as logarithm of numbers less than 1 or logarithm of numbers greater than 1. For numbers greater than 1 is where you have your maybe one logarithm of numbers like 1.3, 292.2, or 95, and the rest. Are you following me now? But for the logarithm of decimals like this, it's actually the logarithm of numbers less than 1. And so this will give you minus 5 plus what now? Now you have 60 under 3 with a difference of 8. 60 under 3 with a difference of 8. So we look for 60. We have 60 under 0 here. Now 60 under 3 will be what? 0. This is it here. 7803. Now with a difference of 8. We look for under the same 60. We trace it like this. A difference of 8 gives us what? 6. So you add 6 to the last digit. 3 plus 6 gives us 9. 0, 0.87, and then you have 0 here. So this gives us what? 0.7809. Are you following? So you have minus 5.7809 minus 5.7809. Like I said again, let's find the logarithm of these particular three values here. We have 81.4, 400.00, 37.13. 81.34. The power of 10 here is what? Is 2. This time is this number is greater than 1, so the power of 10 here is positive. Take note of the difference. I want you to take note of the difference between the two. That's I'm actually finding the logarithm of this one also. And we'll be using this to solve the next questions on the board. Okay. You have 2 plus 81 under 3 with a difference of 4. What's 81 under 3 now? This 81 under 0, under 1, 2, 3. This actually is what? 0. This actually what? 81 under 4, under 3, sorry, is actually what? 0.9101 with a difference of what now? With a difference of 4. So we trace this same 81 straight. Difference of 4 gives us 2. So we add 2. So we add 2 to the last digit here. Are you following? That's 3, 0, 1, 9, 0 point. So you add this now. You have 0.9103. This gives us what? 2.9103. Now, let's find the logarithm of this number 400.00. First of all, we get the integer, right? The integer is what? The power of 10 here is what? Oh, sorry. This is the power of this. Here, we have a power of 1. You have 400 here, and this is a power of 2. Not 1, not 3, 2. Why? Because we have 0, 1, 2. Take note. How do we get the power of 10? 0, 1, 2. If it's the highest place value there is units, the value of 10 of the power of 10 will be 0. If it's tens, the value of the power of 10 will be 1. And if it's hundreds, the value of the power of 10 will be what? 2. So 2 plus 40 under 0 with a difference of 0. So 40 under 0 is what? 6021, Abi. 0.6021. With a difference of 0, what do we have? We have the same value. So you have 0.6021. Now, this gives us what? 2.6021. Moving very quickly, very quickly to the value of this. Our integer will be what? 1, because this is 10 to the power of what? 1. Okay, plus now 37 under 1 with a difference of 3. 37 under 1 with a difference of 3. We look at 37 under 1, which is 0.5694 with a difference of what? 3. 5694 with a difference of 3 gives us what? 3. 0.5697. Now this will give us 1.5697. Okay, 1.5697. Now take note of the differences between your log of numbers greater than 1 and the logarithm of numbers lesser than 1. This one here is the logarithm of what? Of numbers lesser than what? Than 1. Why this is the logarithm of numbers greater than what? Than 1. Okay, now we'll be dealing with the anti-logarithm of numbers. So using the anti-logarithm of numbers, we can convert numbers from their logarithm form back to the ordinary numbers, back to becoming ordinary numbers. How do we do that? Look at the first one here. We have 2.2776. We have our anti-log table here. So to find logarithm, we use the log table. To find anti-logarithm, we use the anti-logarithms table. Now, anti-logarithms of numbers. You have 2.2776. First of all, what we do first is that we convert whatever you have here before the decimal point. Whatever you have before the decimal point becomes the power of 10 automatically. It automatically becomes the power of what? Of 10. It automatically becomes the power of 10. And then whatever you have after the decimal point now ends up becoming the value you use to multiply this power of 10. What do I mean? Now here you have what? 2776. This will be 27. We shift our gaze from this first 2 here. We focus on this place here. You have 27 under 7 with a difference of 6. Now 27 under 7 will be what? This 27 under 0. We have 27 under 3 here. 27 under 6. 27 under 7 will give us what? It gives us 1892. Now with a difference of what again? Of 6. So add 6. That is 1, 2, 3, 4, 5, 6. The difference of 6, we have 3 here. So you have 1893. Sorry, 95. 1895. Now, how do we write this? We write 1.895 times 10 raised to power 2. 10 raised to power 2 is actually what? 100, right? So you have 1.895 times 100, which will give you 189.5. Yes. For the second one, first of all, we convert the power of 10 to what? 0. Now, 6521. 6521 is our focus here. So we have 65 under 2 with a difference of what? 1. 65 under 2 with a difference of what? Of 1. 65 under 2 gives us what? 4487. 4487. 65 under 2 with a difference of 1. You trace it here. The difference of 1, you have 1. So plus 1. Add 1 to the last digit. You have 4488. Now put the decimal points here. Remember, you are going to first represent it in standard form. When you are converting from logarithm back to numbers, you first convert it to standard form, then to numbers. That's why I actually emphasized on standard form before we dive further into the class. So you have 4.488 times 10 raised to power 0. 10 raised to power 0 is what? 1, right? So you have actually 4.488. This is our answer. Now, the third one, you have 3.8320. What do we do first? The power of 10 has to be what? 3, which is the what? The integer in our logarithms. Then we focus on 8320. Now 8320 is 83. In our anti-logarithm tables, please do take note. 83, 8320. 83 under 2 with a difference of 0. It means there's no difference, right? Take note. 83 under 2 with a difference of 0. So you have 83 under 2, which gives us what? 6792. 6792 with a difference of 0. We now give us what? We can now write this as what? 6.792. 6.792 times 10 raised to power 3. 10 raised to power 3 is what? 1,000. That's 6.792 times 1,000, which is what? 6,792. The last one, which is minus. Now take note, this is what? Minus, right? I told you this indicates a negative power of 10. So this is times 10 raised to power minus 2. 4191. What is 4191? That's 41 under 9 with a difference of 1. 41 under 9 gives us what? 2624. 2624 with a difference of what? 1. 41 under 9 with a difference of 1, which is actually 1. So add 1 to it, you have 2625. Now 2.625. Always place the decimal point after the first digit. After the first digit when you are converting to standard form is equals to what? Now this is times 10 power 2 minus 2 abi. That's 2.625 times 0.01. Take note. Now where this 1 starts from is where you put your 2 and you write the remaining values. This will actually give us what? 0.02625. That's our answer. And this is how we convert using our anti-logarithm table to find the anti-log of numbers. Quickly, let's find the value of this. How do we find this raised to power 4? It's quite simple. Now, we find the log and we multiply it by 4, like I just said. So it should just be what? 4 times what? Log 59.4. Remember, the law of logarithm will only apply to a particular number when you have converted it to its logarithm form. Take note, the law of logarithm will only apply to a particular number once you have converted it to its logarithm form. If it is still in the other number, in the form of the other number, you cannot apply the laws of logarithm directly to it. Okay, and this one will be what? 3 log 9 log 3.19, and this will be what? 2 log 42.22. Now this will now be 4 times what? We got our log 59.4 to be what? If you remember maybe from the beginning of this class, our log 59.40 is 1.7738. 1.7738. While log 3.19 is what? 0.5038. And the third one, which is 42.22, is actually what? 1.6255. Now when you multiply this by this, we get 7.0952. And then when you multiply 3 by this, we get 1.5114. 1.5114. And the last one, when we multiply 1.6255 by 2, we get 3.251. Now, if you want to confirm if our answer is correct, we can multiply this one to the power of 4 and then convert this one to the numerical value by what? By using our anti-logarithm table. Do you remember what I taught you? Using our anti-logarithm table. If you multiply this one by itself 4 times, multiply this one by itself 3 times, you multiply this one by itself 2 times. This is what we'll actually get when you convert this one through your anti-logarithms table. Now, we'll be moving straight forward to the what? To the roots of logarithm. Now, roots are simply what? Fractional indices. That's why I have to write this law here. Roots are simply what? Fractional indices. Take note. So, for example, if you have 9 raised to the power 1 over 2, it's actually saying you should find the square root of what? Of 9. The reason why we don't put 2 here for square root is because we have always been solving it that way for in mathematics. We have 2 as the root here. We just put the square root sign, the root sign, because this actually means what? Square root. But when you have something like 81 raised to the power 1 over 3, for example, what you actually do is that what? You write a small 3. Sometimes on your calculator you see a sign like this. This is actually showing you cube root. The cube root of whatever number is inside here. Okay. And so what you actually do is what? If you apply the same law of what? Logarithms. So if you have, for example, 81 raised to the power 1 over 3. If you find the logarithm of 81, you can just simply multiply it by what? 1 over 3. It's that simple. And you can also find this by doing what? By multiplying what? Log 9 by 1 over 2. It's also that simple. So the difference between this and this is that you'll be multiplying the power. When you're getting the power of the number, you'll be multiplying it by whole numbers. But when you're getting the roots, you'll be multiplying the logarithm by fractions. It's that simple. Now, we've been given these 3 questions to solve. We have to find this particular roots. How do we find the root of these particular numbers? It's quite simple. First of all, we apply this law I just wrote here. Then we apply this one. Now, this law most likely is to be applied when we are dealing with roots of what? Of numbers. You are about to solve roots of numbers using logarithms. You apply this law first, then you apply this one. But if you are using power, I think this law should be enough for you. Okay, moving on. We have this. I've told you before that when you see the sign, this root sign, without any small number attached, if the number is a big number, for example, if you have a number like, and the number is big like this is a surd question, or this is a surd. Are you getting me? This is surd. This is 3 whole number times root 15. But when you have something like this, and the 3 here is small, this is actually the what? The cube root of what? Of 15. This is the cube root of what? 15. Take notes. Take notes. Now, it means this is actually the square root of what? Of 81.34, right? And this can be written as what? 81.34 raised to the power 1 over 2. 81.34 raised to the power 1 over 2. This can be written as what? 400.00 raised to the power 1 over 2. And this can be written as what? Take notes. We have a small 3 here. So this is what? 37.13 raised to the power what? 1 over 3. Are you following me now? Raised to the power 1 over 3. Now, we are moving from this law now. We are moving towards this one, right? When we get the logarithm of this value, log 81.34, all we have to do is what? Multiply it by this power. Do you remember now? And we do the same for this one. When we find the logarithm of this one, we multiply it by this power. And when we find the logarithm of this one, we multiply it by what? 1/3. Invisible number here signifies square root, and when you have a number there, it signifies that particular root. So if it's 3 that is there, it's cube root. If it's 4, you find the fourth root. Very quickly, we've checked our logarithm table and we have discovered that this one is what? If you remember, when I was teaching you how to convert from numbers to logarithm, the logarithm of 81.34 is 1.9103. 1.9103. What do? We multiply it by this fraction, Then we multiply this one by this fraction also. Now, log 400.00 is 2.6021. And this one is actually what? Times whatever you are getting here. Now, log 37.13 is 1.5697. 1.5697. Now, multiply this by half, that's by 0.5. We have 0.9551. 0.9551. Now, multiplying this by 0.5, will give us 1.3010, and the last one, multiplying this by 1/3, gives us 0.5323. Take note, when you are dealing with logarithms, logarithm of values like this, the last digit, because you are using a 4-figure table, right? The last digit might not be so accurate, but approximately you should have your answer. Now, if you use your calculator to find the square root of this directly, you use your calculator to find the square root of the roots of all these values directly, and you convert these two numbers, that is, you find the anti-logarithm of this, you will actually do what? Get the same value. So we come to the end of the class. If you know you've benefited from this class, do well to subscribe if you have not subscribed before, like and share. Have a nice day.